Hello, back again. So what we're doing this week and what you guys are doing on Monday is you guys are going to be reading your articles or sections of the book, and I just want to make sure that we are all on the same page about what I want. We're going to have an essay. It's going to involve this, so what factors influence the population? And what I'll be doing is reading the sections of the book that will be covered in class uh, by the people reading the book. Um, but just to make sure we get what we want, I've already got one up here, climate, and as I'm reading, I will be adding to this list. So moving right along, I'm going to be on section 2.2, where it talks about population density. And again, I'm going to try to not go off on too many tangents and just read it. And as I'm reading, I will stop it and add the list. Got it? Here we go. Population density. Population density can be computed in several ways. Arithmetic density is the most frequently used density measure. Density was defined in Chapter 1 as the number of people occupying an area of land. Arithmetic density, physiological density, and agricultural density are examples of measures of population density that geographers use to describe the distribution of people in comparison to available resources. Arithmetic density. Geographers most frequently use arithmetic density, which is the total of objects in an area. In population geography, arithmetic density refers to the number of people divided by the total land area. To compute the arithmetic density, divide the population by the land area. Figure 2.23 shows several examples, and again, you can go to the book to check that out. Arithmetic density enables geographers to compare the number of people living on a given piece of land in different regions of the world. Thus, arithmetic density answers the where question. However, to explain why people are not uniformly distributed across Earth's surface, other density measures are more useful. Physiological density. Looking at the number of people per area of a certain type of land in a region provides a more meaningful population measure than arithmetic density. Land suited for agriculture is called arable land. In a region, the number of people supported by a unit area of arable land is called the physiological density. And again, see interactive map 2.24. It'll give you another look, but you can actually find other sources on the internet to find the physiological density. Comparing physiological and arithmetic densities helps geographers understand the capacity of the land to yield enough food for the needs of the people. In Egypt, for example, the large difference between the physiological density and arithmetic density is shown in figure 2.23, indicates that most of the country's land is unsuitable for intensive agriculture. In fact, all but 5% of Egyptians live in the Nile River Valley and Delta because it is the only area in the country that receives enough moisture by irrigation from the river to allow intensive cultivation of crops. Agricultural density. Two countries can have similar physiological densities but produce significantly different amounts of food because of different economic conditions. Agricultural density is the ratio of the number of farmers to the amount of arable land. Figure 2.23 shows several examples. Measuring agricultural density helps account for economic differences. Developed countries have lower agricultural densities because technology and finance allow a few people to farm extensive land areas and feed many people. To understand relationships between population and resources in a country, geographers examine a country's physiological and agricultural densities together. For example, the physiological densities of both Egypt and the Netherlands are high, but the Dutch have a much lower agricultural density than the Egyptians. Geographers conclude that both the Dutch and Egyptians put heavy pressure on the land to produce food, but the more efficient Dutch agricultural system requires fewer farmers than does the Egyptian system. So I've just read pages 38 and 39, and already the way I'm thinking about this factors in population. We've got a couple of bold terms. Number one, arithmetic density. That's not really going to tell us um, a whole lot about the factors influencing population. Um, but the more densely populated that little general area is, that will definitely impact growth. And there are a lot of ways that you can look at that. So if you have a high arithmetic density, you usually have a lot of people in a confined space. But other countries have less arithmetic density because they might have a lot of space and their people might be concentrated into a few areas. So physiological density, and again, if you just go to the book, go right to the paragraph about physiological density, you'll see that in a region, the number of people supported by a unit area of arable land is called the physiological density. So instead of just putting physiological density down, what you probably want to do with finding your factors in population, or at least influencing population, you probably want to write down arable land. Like the amount that you have there, if you have a lot of land that can produce food, that means you can probably produce a lot more people. Or plain and simply, yeah. If you have a piece of land that can produce a lot of crops, or you can raise animals on it that you would later use for your food source, then that's great. That's also a little bit different from climate, because you might have a really good climate, but if the development of the civilization in that given area takes up a lot of that arable land, then that definitely will have an impact on population. Moving on to agricultural density, that's the other bold term on these 2 pages. Agricultural density is the ratio of the number of farmers to the amount of arable land. So that's a little bit different from physiological density. Physiological density is just the number of people supported by a unit area of arable land. Agricultural density is the number of farmers to the amount of arable land. So not only do you have to have land that can produce things for you, be it a food source or the ability to raise animals, agricultural density tells you the importance of having skilled people in your area to take care of that arable land. So I'm going to leave it at these 2 for right now on these 2 pages on population density. So climate we got from pages 36 and 37. Arable land, or at least the amount of arable land, which we've got down here, we found this in population density.